A small orange berry, growing wild across the coldest regions on Earth, contains 12 times the vitamin C of an orange. It is one of the only plant sources of a fatty acid previously thought to exist mainly in fish and human skin. Soviet cosmonauts consumed preparations made from it in orbit. Siberian villagers survived winters on it when supply chains collapsed. It fixes its own nitrogen, grows in sand and salt, and asks nothing from the soil it restores. In Russia and China, it is cultivated on millions of acres. In the West, most people have never heard its name. In the mountains of Tibet, above the tree line where almost nothing grows, there is a shrub that produces fruit in autumn. The berries are small, bright orange, and clustered so tightly along the branches that they appear painted on. At altitudes exceeding 12,000 feet, in thin air and frozen soil, this plant fruits reliably, year after year, while crops far below fail from frost. The vitamin C concentration in these berries is extraordinarily high. Laboratory analysis, conducted repeatedly across multiple decades and continents, has returned consistent results, between 400 and 800 milligrams per 100 grams of fresh fruit. Some samples, harvested from high-altitude populations, have tested above 1,200 milligrams. An orange contains roughly 50 milligrams per 100 grams. This is not a marginal difference. This is an order of magnitude. A single handful of these berries delivers more vitamin C than a day's worth of citrus. And unlike citrus, this shrub survives temperatures of 40 degrees below zero. It grows where oranges cannot be imagined. But the vitamin content is only the beginning. The oil pressed from these berries contains a fatty acid that is rare in the plant kingdom. It is called omega-7 or palmitoleic acid. In nature, it appears most abundantly in the fat of cold water fish and in human sebum, the oil that protects skin. Plant sources are almost non-existent. Macadamia nuts contain small amounts. This berry's oil contains 30 to 35%. This makes it, by a significant margin, the richest plant source of omega-7 on Earth. A shrub that survives Arctic winters, grows without fertilizer, and produces berries with the vitamin density of concentrated supplements and a fatty acid profile found almost nowhere else in the botanical world. And yet, in most of the West, it grows only in obscurity, in test plots, in the gardens of specialists, in hedgerows planted and then forgotten. The earliest written references appear in Tibetan medical texts dating to the 8th century. The berries, the leaves, the bark, all were catalogued for their uses. Tibetan physicians understood the plant as strengthening, as restorative, as something given to the weakened and the recovering. But the plant's history extends further back than texts. In ancient Greece, the shrub was known and named. The name itself carried meaning. It translated roughly to shining horse. The story, repeated across sources, was that horses fed on the leaves and berries developed unusually glossy coats. Whether this was observation or legend is unclear, but the association was strong enough to persist for centuries. The armies of Genghis Khan, moving across the steppes of Central Asia, reportedly carried the berries as provisions. The Mongol expansion covered terrain where little grew, and winters killed the unprepared. A fruit that could be dried, that could survive months of storage, that could prevent the bleeding gums and loosening teeth of scurvy. This was not a luxury. It was logistics. The plant grew wild across a vast range, from the Atlantic coasts of Europe to the mountains of western China, from Scandinavia to the Himalayas. It colonized sand dunes, riverbanks, mountain slopes, coastal cliffs. Wherever soil was poor and competition was low, the shrub established itself, often in dense thickets that nothing could penetrate. This was not incidental. The shrub was armored. Its branches carried thorns, sharp, long, capable of tearing skin and clothing. Animals that tried to browse it learned quickly. Humans who tried to harvest it without care bled for their effort. But those who understood the plant worked with it. In Scandinavia, in Russia, in the high valleys of Nepal, communities developed techniques for harvest. The berries were picked by hand, carefully, or the branches were cut and frozen, then shaken so the berries fell cleanly. The fruit was pressed for juice, dried for storage, rendered into oils that were applied to skin and consumed through winter. The thorns that made harvest difficult also made the plant valuable in another way. Planted as a hedge, it formed a barrier that no livestock could breach. In regions where fencing materials were scarce, this shrub served as a living wall, self-maintaining, self-repairing, requiring nothing but time. And beneath the soil, something else was happening. The roots of this shrub, like those of legumes, formed nodules that housed nitrogen-fixing bacteria. The plant pulled nitrogen from the air and deposited it in the soil. Where it grew, fertility accumulated. Degraded land, planted with this shrub, became capable of supporting other crops within a few years. This was not fertilizer that had to be purchased. This was fertility that grew itself. The Soviet Union understood what this plant could do. Beginning in the 1940s, Soviet agricultural scientists conducted extensive research on the shrub. They developed improved cultivars, varieties with larger berries, fewer thorns, higher oil content. They established plantations across Siberia, in regions where few other fruit crops could survive. They processed the berries into juices, oils, and medicinal preparations that were distributed through state channels. By some accounts, the Soviet space program incorporated products made from this plant into cosmonaut nutrition. The logic was straightforward: a concentrated source of vitamins and protective fatty acids, shelf-stable, lightweight, and produced domestically without dependence on imports. Whether cosmonauts consumed it for radiation protection, general nutrition, or both, the inclusion reflected a level of institutional confidence in the plant's value. When the Soviet Union collapsed in 1991, supply chains across the former republics fractured. In Siberia and Central Asia, communities that had depended on state-distributed food found themselves isolated. The collective farms that had grown the shrub continued to exist, but processing infrastructure failed, distribution networks dissolved. And yet the shrub remained. It grew along roads, in abandoned fields, in the margins of villages. People who remembered how to harvest it, how to press it, how to preserve it. Those people fed their families through winters when nothing else was available. The plant did not require the state. It had never required the state. It simply grew, as it had grown for millennia, in soil too poor for anything else. In the West, the story was different. The shrub was known. It had been introduced to coastal regions of Europe for erosion control, to stabilize sand dunes and cliffs. It grew in Britain, in Germany, in Scandinavia. But it was not cultivated as food. It was not processed. It was not sold. The reasons were practical. The berries were intensely tart, sour enough to pucker the mouth, acidic enough to require sweetening or dilution before most palates could tolerate them. This was not a fruit that could be eaten fresh from the bush like a blueberry or a strawberry. It required processing, and processing was difficult. The berries were small, clustered tightly against thorny branches, and prone to bursting when handled. Mechanical harvesting was nearly impossible. Machines crushed the fruit before it could be collected. Hand harvesting was slow, painful, and expensive. Workers bled. Yields per labor hour were low. The oil, though valuable, was difficult to extract in quantity. The juice, though nutritious, had a shelf life measured in days unless frozen or preserved. There was no infrastructure, no supply chain, no established market. And the plant spread. It sent up suckers from its roots, colonizing ground that had not been planted. In tidy agricultural systems, this was a problem. In commercial orchards, it was a liability. The shrub could not be contained without effort, and effort cost money. The West looked at this plant and saw thorns, saw difficulty, saw a product with no market, and a growth habit that resisted control. The nutritional content was irrelevant if no one could figure out how to sell it. and so the shrub remained on the margins, literally. It grew on coastlines, on roadsides, on the edges of fields. It was classified in some regions as invasive. It was removed in some places as a nuisance. The knowledge of what it contained, of what it had done, of what it could still do, that knowledge did not circulate. The plant did not fail. The market failed to find a place for it. Modern nutritional analysis has confirmed what traditional use had long suggested. The vitamin C content is not disputed. The omega-7 concentration is not disputed. But the profile extends further. The berries contain significant levels of vitamin E in multiple tocopherol and tocotrienol forms. They contain carotenoids, beta-carotene, lycopene, zeaxanthin, at concentrations that give the fruit its intense orange color. They contain flavonoids, phenolic acids, and other compounds that have attracted research interest for their antioxidant activity. The oil, extracted from both the fruit pulp and the seeds, has distinct compositions. Pulp oil is rich in omega-7 and saturated fats. Seed oil is rich in omega-3 and omega-6 in balanced ratios. Both have been used in cosmetic and dermatological applications, though these are not the plant's primary historical uses. From an agricultural perspective, the shrub offers characteristics that are increasingly relevant. It tolerates drought. Once established, its deep root system accesses water that shallow-rooted crops cannot reach. It tolerates salt. Coastal populations grow in spray zones where soil salinity would kill most fruit trees. It tolerates cold that destroys orchards across temperate zones. It tolerates poor soil, and more than tolerates it, it improves it, depositing nitrogen year after year through its root nodules. It is a pioneer species, one of the first plants to colonize disturbed or degraded land. Where mining has stripped soil, where overgrazing has compacted earth, where erosion has removed topsoil, this shrub can grow. And where it grows, other plants eventually follow, nourished by the nitrogen it leaves behind. It produces fruit within 3 to 4 years of planting. It continues producing for decades. It requires no annual replanting, no purchased fertilizer, no irrigation once established in appropriate climates. The thorns, which make commercial harvest difficult, make the plant valuable for other purposes. As a living fence, it excludes livestock, deters intruders, and provides habitat for birds that nest protected within its branches. The density of its growth blocks wind, reducing erosion and protecting adjacent crops. In China, the shrub is cultivated on over 3 million acres, more than any other country. The fruit is processed into juices, oils, and health products that constitute a significant domestic industry. In Russia, cultivation continues, though at lower levels than during the Soviet era. In Mongolia, in Nepal, in parts of Scandinavia, small-scale harvest and processing persist. In North America and Western Europe, the plant remains marginal. Some nurseries sell it. Some permaculture designers incorporate it. Some foragers know where it grows wild. But it has not entered mainstream agriculture, mainstream commerce, or mainstream awareness. The shrub is called sea buckthorn. The name reflects its habitat. It grows readily along coastlines, though it thrives equally in mountains, in continental interiors, in any terrain that is harsh enough to exclude its competitors. It is not related to true buckthorn. The resemblance is superficial, and the confusion is unfortunate. It grows today in temperate and cold regions around the world. In North America, it is found in Canada and the northern United States, sometimes wild, sometimes cultivated, often overlooked. In Europe, it lines coasts from Norway to Greece. In Asia, it covers mountainsides from the Himalayas to Siberia. The plant is dioecious. Male and female flowers grow on separate individuals. Both are needed for fruit production. The ratio recommended by growers is 1 male plant for every 6 to 8 females, positioned to allow wind pollination. Without males, females produce no berries. Planting is typically done from container-grown stock or root cuttings. The shrub establishes quickly in full sun and well-drained soil. It tolerates sand, gravel, and low fertility. It does not tolerate shade or waterlogged conditions. Once established, it spreads through root suckers unless contained by barriers or regular removal. Harvest occurs in late summer to early autumn, when berries are fully colored but still firm. Timing is critical. Overripe fruit bursts at a touch. Some growers freeze branches before picking, which allows berries to be shaken off cleanly. Others cut entire branches, sacrificing some future yield for ease of collection. The berries can be pressed raw for juice, though the flavor is intensely sour, and most preparations add sweetener or blend with other fruits. The juice can be frozen for long-term storage. The oil, extracted by cold pressing or centrifugation, is shelf-stable and has been used both internally and externally. In the garden, sea buckthorn is not a tidy plant. It sends up suckers. It grows thorns. It forms thickets, if allowed. But for those who want a perennial source of nutrition that asks almost nothing of the soil, that survives winters that kill other fruits, that provides its own fertility and its own fencing, for those who want a plant that gives more than it takes, sea buckthorn has no equal. It never disappeared from the places that needed it most. It still grows in Siberian villages, on Himalayan slopes, along Scandinavian coasts. It fed people through winters when nothing else could. It fed cosmonauts in orbit. And it is still here, still fruiting, still waiting to be recognized again. The knowledge was always here. We just stopped looking.